In this video, we will use implicit differentiation for equations with multiple variables. So we're given an equation where x, y, and z are all mixed together on both sides of the equation, and we're asked to compute partial derivatives of z with respect to both x and y. So first let's do x. So we'll start by just writing what we're going to do. We're going to just take the derivative of both sides of the equation with respect to x. So I'm just going to take the partial derivative with respect to x of the whole thing. Okay, so let's do it. So remember here, x and y we're treating both as independent variables, meaning for the sake of doing this derivative, y is a constant. Y does not depend on x, but z does. So z we will pretend is a function that depends on x, where y is not. It's just another independent variable. So, in this first term, y is just a constant, so it just comes out. So this is just y times partial z partial x. And similarly in the second term, e to the 2y is just a constant, and the derivative of x is just 1. Okay, on the right hand side, the derivative of sine x is certainly just cosine of x. And now since z is a function of x, we have to use the chain rule here. So minus 3z squared times partial z partial x. And now to finish, we just use algebra. So just move things around and try to solve for partial z partial x. So let's move the two terms that have partial z partial x to the left hand side and factor it out. So we get a y and a 3z squared. And move the other terms to the other side. So we have the cosine x, and we have to move the e to the 2y over. And then just divide and we're done. So we get cosine of x minus e to the 2y all over y plus 3z squared. So there's our answer to part A. There's partial z partial x. Now for part B we do exactly the same thing, but we just take the y derivative everywhere. So let's start by just writing what we're going to do, but not quite doing it yet. Let's just formally write down that we're taking the partial derivative with respect to y of both sides of the equation. And now again, x and y are independent variables. So now, since we're taking the y derivative, we treat x as if it's a constant everywhere, and z as if it were a function that depended on y. So now for this first term, y times z, we have to use the product rule, because both factors depend on y. So if we use the product rule, the derivative of y is 1 times z plus y times the derivative of z. In the second term, x is just a constant, and then we take the derivative of e to the 2y, which is 2 e to the 2y. Well, this first term on the right, sine of x, doesn't depend on y at all, so the derivative is 0 there. Again, x is a constant, so sine of x is a constant. And we have to use the chain rule for the second term. We get minus 3z squared times the derivative of z. And again, just like above in part A, we now just use algebra. We shuffle things around and try to solve for what we want, which is partial z, partial y. So we'll move those terms to the left. We have this term that was already on the left, and this term that we move over from the right. And move everything else over. So we have to move over the z, and the 2x, e to the 2y. And finally just divide and we're done. So partial z, partial y equals, I'm going to factor the negative out of this. And just put the negative on the whole fraction. And there we have it. Here is the derivative of z with respect to y.